Okay, now we're going to talk about electrons, and for the purposes of electrons in high school chemistry, you can assume that they have no mass. In fact, their mass is so small that we don't calculate them into the atomic mass. There is a mass present, but for our purposes, ignore it. In fact, it's 1/2000th as large as a proton or a neutron. In other words, a proton or neutron is 2,000 times heavier than an electron. So when we figure out electrons, we first have to look at the atomic number. The atomic number of sodium is 11. So for both of these, I'm going to write 11. Now, these are the same isotope of sodium, it's just that they have different charges, therefore their electrons are different. This sodium and this sodium have an atomic mass of 23, which we find on the periodic table. So I'm going to go ahead and write 23 on both. So 23 and 11, 23 and 11. We could probably just write some assumptions here. We have protons equal 11. The neutrons equals 12. Which we do by calculating or taking 23, subtracting 11, we get 12. Now, electrons are going to be different for either one. In something where it is in a substance that is neutral and a substance that has a charge, you're going to look in this dotted green area where I circled for the charge. Since there's nothing written here, this charge is equal, and the protons have to equal the electrons. So here, electrons equals 11. Now this one, protons equal 11. Electrons, since they're negative, there has to be one fewer. So electrons in an ion of sodium is 10. 11 protons, 12 neutrons, 10 electrons. This one, 11 protons, 12 neutrons, 11 electrons. Okay, sodium's electron configuration is 281. Now it is 281 because it fills in from the inside going out. It is considered to be in the ground state. Now I'll draw for you right now. This is the nucleus with the protons and the neutrons. We have orbital number 1, or n equals 1. We have orbital number 2, or n equals 2. This is called a quantum level. And orbital number 3, or n equals 3, we have 1 electron. So I'm going to go ahead and draw the electrons where they belong. We have an electron here, 1 here, 1, 2, 3, 4, 5, 6, 7, 8, put little dashes. And we have 1 electron in the outer orbital. 2, 8, 1. This is considered the ground state. However, what would happen if I took one of these electrons, I added energy, and one of these electrons bounced to an outer orbital? So now I'm going to have 2 electrons, 1, 2, 3, 4, 5, 6, 7, and 1, 2. This is considered the excited state. Now something that is in the excited state, what we do to figure out if it's ground or excited is you total up the number of electrons. 2 plus 8 plus 1, that equals 11. I look for atomic number 11, that's sodium. On the periodic table, match up the electron configuration. If it's the same, then it's ground state. If it's different, it's excited. Try it here. 2 plus 7 plus 2. 2 plus 7 is 9, plus 2 is 11. Again, 11 tells us to go to sodium. This electron configuration is different than the periodic table. So this is exciting. Ground state, periodic table, excited state, different, but still totals the same amount of electrons.